Welcome to PClarkCalc. This is practical calculus for the busy math student. I'm P. Clark, and in this video we're going to take a look at integration using the general exponential rules. These would be integrals in the form of e to the u. So let's get started. Here you have an example of an integral that we're going to need to use a u-substitution on. So we're going to showing an example of the general form of the exponential rule, the integral of e to the u du, which is e to the u plus c. And there are a few indications here that the u substitution is going to work. And one of the most common types of indicators is the 1 degree drop. When we see the quantity we're calling u in an integrand, which in this case would be the exponent, we see that that's degree 2, u here is 3x to the second, and then we see a 1 degree drop to the second factor in the integrand. That tells us that most likely we have a good chance that this u sub is going to work, at least if it's showing up in your homework problem. So we go ahead and we calculate the du at that point, and so we see that du is 6 times x dx. And don't fall into that habit of just kind of trying to assign du to something. Du is a calculation. If you're saying u is 3x squared, du is the differential, so that's the derivative of u times dx. So we see here what we like to call the almost du case. Almost meaning we're off by only a constant multiple factor, and that means that we can go ahead and fix this. If you needed the power of x, then you're in trouble at this stage of the game, but we knew that wasn't going to happen because we saw that 1 degree drop occurring between u and the other factor. So if all we have to do is fix the coefficient, we can go ahead and do that. Now one option here to get started might be, rather than to try to convert the factor of 4 into the 6 that we need, is to just use the constant multiple rule and remove the 4 from the integral. Again, the only thing that can go in and out of an integral is a constant factor. But if we do that first, then we're looking at 4 times the integral of 1x e to the 3x squared. And that just makes the arithmetic a little easier. You don't have to wrestle with fractions or anything. So now we see that we're off by a factor of 6 on the inside of our integral. So we just go ahead and we correct that. So we multiply by 6 on the inside, and then we balance it by dividing by 6 on the outside. And so when we rewrite it in the u variable, we're dealing with 2/3 times the integral of e to the u. That's this part of the integral. It goes here. And then the other factors around the e to the u are combined and multiplied together, and they become the du. And in any kind of a u substitution like this, if we can't get the du factor to occur, then we just can't use the technique, because we're going to integrate with respect to the u variable now. But once we get there, most of these, once you get here, they're all pretty similar. We just go ahead and apply the rule. Integral of e to the u du is e to the u plus c. A little bit redundant if you're doing a lot of them on the homework. That's the easy part. And then we want to back substitute here in the indefinite integral. If we begin in the x variable, we want to end in the x variable. So 2/3 e to the 3x squared plus c. And that's our antiderivative. So nice example, kind of a typical case of the general version of the exponential rule. Keep an eye out, as always, when you're doing u-subs for those du indicators, things like this. So the 1 degree drop when you have these algebraic factors, very common. Here at PClarkCalc, we specialize in practical calculus for the busy math student. But if you feel like you want to learn some more, you can find my textbooks on Amazon. They're nice priced. And until next time, I'll see you. I'm P. Clark.